The example is f of x is equal to x squared plus 2x minus 8. We can see that it is a trinomial function. So as we factor it, this will be the f of x quantity x plus 4 times the quantity of x minus 2.
To find the zeros of it, we must change this factored form into an equation form. Then it will be the quantity of x plus 4 times the quantity of x minus 2 is equals to 0. We must then separate these two binomials for both equals to 0. They would become x plus 4 is equals to 0 and x minus 2 is equals to 0. Then transpose these two. It will become x is equals to negative 4 and x is equals to 2.
Finally, our zeros are negative 4 and 2. The example is f of x equals x cubed plus 8x squared plus 16x.
We can factor it by knowing what's common to them, and it is the x variable.
Therefore, it will be f of x equals x times the quantity of x squared plus 8x plus 16. Since a trinomial came, therefore, and it will be f of x equals x times the square of the quantity x plus 4.
Let's change this into an equation form, and it will be x times the square of the quantity x plus 4 is equals to 0. As we transpose this, it will be x is equals to 0 and x is equals to negative 4. Therefore, our zeros are 0 and negative 4 of multiplicity 2. Why is there multiplicity 2? Because in the equation form, the quantity of x plus 4 is squared, therefore we have negative 4 of multiplicity 2. For example, f of x is equals to x to the 4th minus 6x to the 3rd plus 13x squared minus 12x plus 4.
To factor this, we can use the rational roots theorem, which states that p is a factor of the constant term of p of x and q is a factor of the leading coefficient of p of x. Therefore, our p is 4 and our q is x to the 4th.
Then, we find their factors. The factors of p are positive negative 1, positive negative 2, and positive negative 4. While q has positive negative 1.
As we have found the possible roots of this function, we can now use synthetic division. First, we use 1 and get all the coefficient in this function. Bring down 1, then multiply it to the divisor and we'll have 1. Negative 6 plus 1 is equals to negative 5. Multiply to 1 and we'll have negative 5. 13 minus 5 is equals to 8. Multiply to 1 and we'll have 8.
Negative 12 plus 8 is equal to negative 4. Then multiply it to 1 and we have negative 4. So 4 minus 4 is equal to 0. The function has no remainder. Therefore, 1 is a root of this function. For the next one, we'll use 1 again. Repeat the flow. Bring down 1, then multiply it to 1 and we will have 1. Negative 5 plus 1 is equal to negative 4. Multiply to 1 and we will have negative 4. 8 minus 4, we will be having 4. Then multiply to 1 and then the answer will be 4.
Negative 4 plus 4 is equal to 0. Therefore, the other one is also a root of the function. This one can be a trinomial function of x squared minus 4x plus 4. The equation of this function would be the square root of the quantity of x minus 1 times the quantity of x squared minus 4x plus 4 equals to 0. Factor out the trinomial and we will have the quantity of x minus 1 squared times the quantity of x minus 2 squared equals to 0.